Okay, so welcome this afternoon to everybody for the first LandAware meeting, kickoff event 2020. So we've got a series of presentations this afternoon. We're going to record the whole meeting so that it can go online and you can access it again if you wish to, or look at the presentations again. Everyone will be engaging via the chat, please, during the event. So we'll keep an eye on everyone's comments and questions that are coming through. But at the end, we will have a Q&A session that we will monitor as best as we can with now 106 people in. So we're suggesting that people still write questions in the chat and we'll sort of monitor those and direct them to people as and when, or people can put their hand up to give an answer, but we'll review that towards the end. So our first speaker will be Michaela, and I will be giving everybody a 2-minute warning, so I will interrupt your presentation at 2 minutes. So I hope that that's all right with everybody. Okay, so Michaela, would you like to kick off the first presentation, please?
Sure, thank you, Katie. Okay, let's see, before we try, let's see if I can share the screen now, that it's the real thing. Let's see, share. Do you see the presentation full screen? No notes?
Yes, we do.
Yes, we can.
All right, perfect. Then let me then just go with, because I see this. Okay, it doesn't matter. All right, so thank you for the introduction, Katie. I want to thank Katie also for having coordinated the organization of today's online gathering. You know that this is the first event we are running. It's a newly born network, ours, and so I thank you all of you that are here. Now I cannot see the numbers anymore, but we're more than 100 already before when we started, and you're showing an interest for LandAware. I'm assuming that you are also interested in knowing more about this network, and this is my main task, my main job today, in these few minutes that I will take, not many minutes. As you can see here, the first part of our meeting is indeed devoted to this presentation. Do not worry, I won't be talking for half an hour. It's not only me. I will share the microphone with all the chairs of the different working groups before moving, as you can see here, to a short keynote lecture by Fausto Guzzetti, and then going around the world. We will go to Japan, Spain, then Central America, and finally we will be also hearing from you in the Q&A session. So let's move forward.
Michaela, can I just ask you to move closer to a microphone? There's a comment in the chat. Thank you.
Absolutely, yes. Is it better now, or is it the same? I don't know. Can you tell me if you can hear me, at least, Katie?
Yeah, you were fine to me, but there's a comment.
Okay.
So yeah, thank you.
I will go like that. Okay. All right. So maybe already our website. When back in July, LandAware was officially born, we decided that before going public with the news, we should have set up a website, and indeed we did, with a thorough description of our structure, our aims. I'm assuming that if you are here today joining us in this event, you may also already have discovered the website and also possibly browsed it. Anyhow, I want to say that you may refer to that website at any time for an up-to-date description of the situation and the ongoing situation of the network. Of course, today I present something, but only briefly, the key features of our network. I won't take much time. I want to start with this sentence that highlights the general objectives of this networking effort. LandAware is a network of individuals. Therefore, as you can see here, managers, researchers like me, stakeholders, all interested in sharing experiences, needs, and innovations related to landslide early warning systems. It is essentially that, it's essentially knowledge sharing, collaborative knowledge production or co-production. Of course, with the aim of improving the state of practice in landslide early warning, and ultimately, we may say to save lives, because early warning systems save lives. Let's go back to the characterization of the network. LandAware as a bottom-up structure. It is essentially the working groups that run the show. They are governed, of course, by an executive committee. And within the executive committee, all the working group chairs are. And ultimately, we have a general assembly who directs everything, essentially monitoring the progress of the network, periodically evaluating new challenges, upcoming issues, everything that must be done to run an international association of network. We will go soon into the details of the different working groups, but let me just say a few words about the current executive committee, which I have the honor to preside over. It is 9 of us. Indeed, it's the 9 founding members of the network. I remind you that it was formally born only a few months ago, on the 1st of July of 2020, this year. Yet, after many years of formal and less formal discussions at international level, but I don't have the time to recount that now. As you can see, we are spread worldwide, and also today, the participants are also coming from all over. Although there is a clear European cluster, at least among us, and we are all interested. We have a strong interest in landslide early warning systems, despite the fact that our daily jobs are very different. Because if you see the employers, they range from the US Space Agency, NASA, to the Italian Civil Protection Department for Fausto Guzzetti, from the British Geotechnical Service and the Met Office in the UK to agencies of ministers or other institutions like MVE in Norway, WSL in Switzerland, NILIM in Japan, and also finally to some research and academic institutions like the CNR and my university, University of Salerno in Italy. I want to say that that's not by mistake. It is a clear, we can call it a signature feature of our network. We want to be a group of diverse people with diverse background, engaged, yes, in innovative research on landslide early warning, but of course, at the same time, also in the daily operations of landslide early warning systems. That's something that we want in this network. That said, let's move on to the main operational units of the network, that is the working groups. They are set up to discuss and address specific topics, and thus they have a clear mandate by the executive committee to achieve certain objectives. Most importantly, they carry out activities, and that's what a working group is expected to do, carry out activities either continuously or for a fixed period of time. These activities are, of course, by definition, group activities. So they are carried out by the group members. The group members can be active members, they are called VG associates, or also people that are interested in getting the news from the single working groups. They are called VG observers. And each working group is guided by one or at most 2 coordinators that are called VG chairs. We have currently 7 active working groups. Actually, more probably, I should say, the working groups that are going to be active very soon, we're just about to start with the real activities that I was just mentioning, are these 7. And so now, without further ado, I'm going to call one by one the single VG chairs. And so each one will introduce very briefly, maximum 2 minutes, the single working group. So let's start with Hiro. Hiraki Nakaya is the real name. We call him Hiro. Please, your turn. You can switch on the mic.
Okay, can you hear me?
We can, yes.
Okay. My name is Hiraki Nakaya. I will be chairing this working group 1 catalog with Gloria Dipola from Norway. Objective is to create a catalog, a beacon or a chart for landslide early warning system, which is an evolving system in constant development, and many out there have not been described yet. We know that there are several individual researchers who have tried to create ones, but what we need is an equal ground, everyone can participate type of catalog, a chart. We can enjoy to put our pieces together in one catalog. So we can, in the near future, once created, we can have a common ground, a common denominator to guide our technological management for landslide early warning system. And we can join together to update and recreate, and always is a constant way of managing one kind of technology, which is a landslide early warning system. So because we are working in a public arena, public domain, we cannot expect price mechanism to guide us. For landslide early warning system, we need a certain type of beacon, a chart, so we can all compare our effort together. So in this arena, all countries and everyone is equal. That's our expectation. What we'll be doing is written here as an objective of our working group. So for loose, operational, and in a final development stage, we can put together these pieces to create a puzzle, a chart together. So we expect you to join very urgent manner. By this tiny effort, we will have a good starting point for 7 initial efforts of LandAware. Thank you.
Thank you very much, Hiro. So there was also this slide that you sent to us showing some references about efforts in trying to catalog landslide early warning systems. Let's move on to Stefano for the working group communication networking. Stefano Luigi-Gariano.
Okay, good morning, good afternoon, good evening, everyone. I'm Stefano from the Research Institute for Geohydrological Protection of CNR, based in Perugia, Italy. Currently, I'm involved in 3 working groups, and I'm chairing this communication networking group, in which at the moment we count 30 associates and 40 observers. As the name suggests, very briefly, the working group aims at communicating the main advances, the main activities of the network. So main, let's say, ongoing projects or ongoing activities of single members of the network. This can be done through different media. Mainly, we would like to use our website blog, but also interviews, social media, and so on. And also with the preparation and publication of periodic reports. Another activity is also to create and maintain relationships with similar networks. And so any suggestion, the same is welcome. And finally, the group is also in charge to organize future physical workshops and meetings. And I think everyone's hoping to do this very soon. So the group is mostly devoted to the operative maintenance of the network. We don't have a secretariat or an administrative network, an administrative office. So we should do also this work. And if you are interested in communication and all these communication issues, you want to help us, you are very welcome to join this group. I've already contacted all the associates and observers that already joined the group, and I'm planning to contact the new arrivals. So that's all. Thank you.
Thank you very much, Stefano. And then next group is the one called Communication with Stakeholders. We are just listing them in alphabetical orders. Please, Katie or Joanne, who's talking? I don't know.
No, that's fine. It's going to be me first. So I'm Joanne Robbins from the UK Met Office. So myself and Katie are chairing this working group. I think, as we all know, communication and dissemination is critical for effective early warning. And in order for information to be relevant, useful and usable to stakeholders, we need to understand their needs and the timescales with which they need information and the resolution that they need that information. So this working group is really focused on trying to gather together the stakeholder perspectives, their needs, their understanding of what we can offer, and joining up that scientific link between the stakeholder requirements and what we can offer from the scientific perspective. There's another slide, actually, Michaela, could you go there? Thank you. So in terms of the group itself, we will be sending out emails in early January. And one of the key things we're keen to focus on in the first sort of year is to really gather experiences, particularly from the stakeholder side, but also those that work closely with stakeholders, about their experiences, their engagement practices, how frequently they engage, how that is maintained, because all of these aspects really control how effective an early warning system can be. And based on that, we hope to build a catalogue of different engagement practices, both in terms of those experiences and techniques, but also how that can be maintained going forward from a technical perspective as well. So if you're interested in joining this group, then you can get in touch with myself or Katie, and our emails are here. And we really welcome a very diverse group of people here, because we're trying to gather as much information of stakeholder requirements as possible.
Thank you very much, Joanna. And then, okay, it's my turn now to talk. So this is the working group I am chairing. As you can see, it's called e-learning. The main objective is to design and create what I call the educational products to be used, of course, over the internet as learning experiences. This is a group that is very much going to interact with the other working groups, of course, by definition, I can say. When I'm thinking of educational products, I'm thinking of a wide range of possible things or items. From full-blown short courses or innovative interactive games, as I wrote here, which necessarily require significant amount of effort, to design, to produce, to develop. Also to smaller objects such as digital leaflets that may be addressing specific elements of landslide early warning systems, and also to discussions or interviews, for instance, with managers of operational systems or with different categories of stakeholders, all the way to webinars. In that respect, I can say that maybe today's event and its recording, because we are recording and we will make it available for watching on demand. If we exclude maybe this initial part, presentation part, it is indeed aiming at promoting what is written here, the transfer of knowledge related to, in this case, a range of worldwide experiences with landslide early warning systems, at least for today. I conclude just by saying that I'm looking forward to working with members, observers that already expressed an interest for being in this working group, because as you know, for those of you who are members or observers, you've been asked to express an interest in being part. I can say it now also to the people that are not members already. We are saying from the beginning that more than 3 working groups as associates you shouldn't join, because otherwise you don't have time to go into different activities. But as an observer, you can be observing also whatever working group you want. And so I also hope that after today's presentation, other people will be joining LandAware first and the different working groups, of course, these one or others that you may be interested in. Thank you with that. And I move on. Let's move on to Manfred for his innovations working group.
Hello, everybody from Switzerland. My best regards. I proposed to this committee here that we should have a working group on innovations in landslide early warning systems. And if I would ask you, 124 people now joining us here, what is an innovation for you? I would probably get very different answers. Maybe somebody would say a new sensor monitoring the acoustic emissions of breaking roots or cracking soil. to indicate a forthcoming landslide would be an innovation. Or somebody else from meteorology would rather say a new radar-based nowcasting product is a very excellent development at the moment. Or maybe somebody else from this network here would say that the real-time analysis of social media for warning in disasters is a new innovation. So in the end, I would get very different answers. But I think we all agree that we should exchange about these innovations and tell each other what we are using, how it works, and how we can make use of these innovations. So that's basically the goal of this working group. We want to promote new research innovations. And I invite you, be it if you are a researcher, but also if you are an operator, or if you would like to use these innovations, you are very welcome to join this working group. And we will have a first online meeting in January or February. And I will soon, that means probably tomorrow, send you an invitation so that we can find a suitable date. That's what I can tell you about this working group.
Thank you very much, Alfred. And then we move on. We have the working group called Landslide Early Warning Systems Data. Dalia?
Yes, thank you. So as we all know, foundational to landslide early warning systems is the data to parameterize them and to test them. And so the Landslide Early Warning System Data Group, I will be co-chairing with my colleague Ben Muris from the U.S. Geological Survey. And the goal is to discuss and promote open data and sharing of information that can be useful for landslide model development and parameterization and evaluation. We're going to have 4 main objectives for this work. The first is a review of data needs and opportunities, kind of a survey of the community. We'd like to develop some benchmark data sets. So how can we evaluate our systems against a consistent set of landslide inventories and possibly other information? We want to potentially, in the next couple of years, develop a central repository for this information where metadata can be shared and we can identify what is available. And then also talk about what the applications of this information may be and identify knowledge gaps within this area. So if you go to the next slide. We welcome people. This is going to be a working group, so welcome people that are interested in any of these topics. Again, this kind of goes into more detail on what we are going to explore in each of these areas. We're planning to invite everybody that indicated they were interested in this area to attend our first working group meeting, which we will schedule for January of 2021. An invitation will go out a bit before Christmas, and we really want to encourage people to come with their ideas, ideas of how we can promote and expand data sharing, and also how we can really work together to identify gaps and move this area forward. So with that, thank you so much.
I thank you for the description, Dalia, and I move on to the last of the 7 working groups that we are describing today, Operational National Landslide Early Warning Systems, and it's Graziella chairing it.
Hi, hello everybody from Norway. In this working group, we are talking initially on Operation National Landslide Early Warning, and just to remember to all of you, we have essentially 2 types of early landslide early warning based on the coverage in geographical territorial, which include the global, national, and regional, and a local one. Next, please. So the general objective is to promote the international collaboration, discussing common strength and limitation about the existing operational one, but also those that are as a prototype. And of course, I would like that people join this group if you are especially operator of a national system, or you are a researcher for those that are in development stage. but also if it's possible to assist or be assisted to reach an operational status for those of us that are in development stage. And also because, I mean, if you believe that rainfall-induced landslide are not only a local national problem, but we should look at larger weather conditions that trigger landslide across different countries at the same times. And therefore we need international efforts and especially multidisciplinary efforts. And just 2 examples from Europe, both of them warm period that trigger landslide from the South Europe that trigger landslide in the northern Italy and Norway, or rest of hurricane that in this case, the combination of Maria and Lee that trigger landslide before in Puerto Rico and later on in Norway, Iceland. And yes, I will also send to all of those that have registered as members of this working group a letter invitation for a working group meeting. Thank you very much.
Thank you very much, Graziella. And so to close this presentation, I want to say that up to now means up to the last meeting of the executive committee that was on the 4th of December. We have more than 100 members and 23 observers. Already new applications came, but we still didn't evaluate them. Anyway, I invite all of you that maybe after today's meeting may be interested in joining the network to do so by just simply filling a very simple form that I put here, but you can find it easily on the website. And so if you do it in the next few days, we will for sure before Christmas have a meeting for accepting new members in the network. And so you will be able also to join, as we said now, the activities of the different working groups, and then depending on the ones that you are interested in, because most of them will start soon. Will start after at the beginning of the new of 2021, essentially. But some emails were already sent, as you heard from the different chairs, and things are starting moving. So if you're interested, I invite you to join us by filling the application form. And I want to say that today at noon there were 171 registered participants. Now I don't know if there is a few more, because then I stopped checking and then we had the problem with the network, Google, and I was positively surprised. First of all, many countries, 47 countries from everywhere. But if you look also at the distribution between members that are already members, because they already expressed an interest in being part of this network, and people that are not members yet, there is a lot of you that is here, but still not formally within LandAware. If you're interested, please join LandAware. I think the time that I had is over and we are not late. So I can close this presentation like that. Only one final message for today's interaction here in this event. We have the chat, we have the Zoom chat. Use it also during the event. Now we have a final Q&A session, but if you have some questions, some comments, whatever you want to say to all of us today, don't wait for the final half an hour to write in the chat, because if you do it before, then in the Q&A session, you will be given the floor earlier and your comment or question will be posed earlier. So once you will now listen to the presentations, if something comes to your mind, whatever you want to say, you can use the chat during the event. Thank you very much. And I think I can unshare the screen if I manage to do that, so that we can move on with the event. What is next? Next, indeed, is a keynote by Fausto that I don't know if he's around. Do you know if he's in physically or not?
I am here.
Perfect. Okay, so we don't need your welcome message. You are live. And then after, we will have the pre-recorded presentation. Please, Fausto, the floor is yours.
Okay, thank you. And good afternoon from Rome, and welcome to this LandAware kickoff event. Unfortunately, I will not able to attend the entire meeting because following bad weather in the previous few days in Italy, we are very busy with the aftermath of that. But I have prepared a video of a short talk for you, and I hope you will like it. So enjoy what promises to be a very, very interesting meeting, and ciao to everyone.
Thank you very much, Fausto. So I am in charge of sharing your presentation. I will do it if I manage. We tried before, hopefully it works now. Okay. If there are some problems with the audio, you tell me, you and the others, tell me right away.
Okay.
Hi, everyone. Welcome to LandAware. The executive committee asked me to give a keynote on this kickoff event. They said it would be a bonus for the meeting to have me in the agenda. What they meant really was that I am old and people know me. But here I am, and happy to share my 2 cents on why people should care about landslide early warning systems. And to be clear, I'm not really interested in systems that deal with single landslide failures, but rather in systems that deal with populations of landslides occurring over large and very large areas. These are the systems I call geographical, and my friend Michele Calvello calls territorial systems. But today I want to get into a terminological dispute. And for the sake of curiosity, who got the idea of a geographical early warning system? I'm not sure really, but I like to believe it was Russ Campbell, a geologist with the USGS, when studying the effects of storms in the Santa Monica Mountains of Southern California in January 1969. He wrote that a landslide early warning system can be constructed with 3 major elements: a system of rain gauges recording the rainfall on an hourly basis, a weather mapping system capable of recognizing centers of high-intensity rainfalls in the storm area, and a communication network to collect and manage the data and to inform residents, to inform the population. He then concluded that, I quote, "Such a system is probably well within the capability of existing technology." And this was in 1975, 46 years ago, speaking about having a vision. But it takes time for good ideas to be accepted. 2 years after the work of Campbell, the first prototype system was set up not in the US, but in Hong Kong, followed 7 years later by a system in the San Francisco Bay Area in California. The year after the system in the San Francisco Bay was terminated, a new system was started in Rio de Janeiro in Brazil, followed by a system in Oregon. In 2000, at the turn of the century, 25 years after Campbell's work, there were only 3 operational systems globally. Around 2005, new system became operational in Taiwan, Seattle, and Southern California, and NASA tested their first global system. In 2015, the year of the Sendai Conference in Japan, 15 systems were operational or pre-operational globally. The chart here shows the number of systems per year between 1977 and 2019. Since 2005, we see an increase at a rate of about 1 new system per year, which becomes 1.5 new system per year in the last 5 years. This is, of course, very good. But at this rate, it will take decades before a significant part of the areas affected by landslides will be covered by regional or national systems. And this is why we have recommended increasing the rate, focusing on national systems to cover large areas more rapidly. Surprisingly, at least to me, the literature on landslide early warning system is not really abundant. Still, there are a few what I call must-read papers, and these are two of them. A 2004 book chapter by Ray Wilson, who told a fascinating, really fascinating scientific and human story about the rise and fall of the system for the San Francisco Bay region in California, and a 2010 article in the journal Landslides by Rex Baum and Jonathan Gott, who described landslide early warning capabilities in the US. More recently, two different yet to a large extent complementary review articles were published, one in 2018 by Luca Picciullo and his colleagues, and one in 2020 by myself and my colleagues at CNR. Both were published in the journal Earth Sciences Reviews, which is an uncommon platform for landslide studies. To begin a journey on landslide early warning system, I think these are good starting points. Let me tell you what we have learned from our review. We learned that regional and national systems are in all climate, in all geographical domains, in all seismicity zones, and in a broad range of terrain, elevation, and topographic reliefs. We concluded that early warning system can be operated everywhere with no morphological, climatic, geological, seismic, or tectonic constraints. And this is good news for operational landslide forecasting. The map here shows the distribution of 19 regional, 6 national, and 1 global system, the latter covering from 60 north to 60 south. And it is legitimate to ask if these 26 systems are in the right places. The distribution of non-seismically induced fatal landslide from 2004 to 2016, these are the green dots in the map, shows that areas where fatal landslide are most numerous and therefore landslide risk to the population is high, lack regional and national early warning systems. We then recommend to focus in areas where landslide risk is high, and particularly where the risk to the population is high. We further found a lack of standards for how to deliver the forecast to different audiences, including authorities and even the general public. The chart here shows the variety of choices made by the 26 systems, with practically each system using its own approach, or almost. We think the lack of standards limits the credibility and usefulness of landslide early warning systems. Getting to the conclusion, I think that landslide forecasting and early warning is a really fascinating topic of scientific, technological, and societal interest. And when dealing with the interaction between science, technology, and society, philosophy is crucial. Our analysis of the literature reveals that the system relies almost invariably on the assumption that landslides can be predicted, something that has not been proved or disproved theoretically. I am very much convinced that to a large extent landslide can be predicted, but I am also aware that this remains a difficult task. And this is very well expressed by an economist, Peter Drucker, who, about prediction in general, wrote, "Trying to predict the future is like trying to drive down a country road at night with no lights, looking out the back window." And on prediction, I like to point your attention to an idea I came across recently, expressed by the saying, skin in the game, which means to have incurred risk by being involved in achieving some sort of goal. Nassim Taleb, the author of The Black Swan, in a recent book builds on the idea of having skin in the game and suggests to avoid taking advice from someone who gives advice for a living, unless there is a penalty for their advice. Think about it. As landslide forecasters, we give advice for a living, and we should feel and be ethically involved with what we do with our forecasts. This is the societal part of the game. And to you, the braves willing to play the game, let me say that there are two groups of people who make predictions: fortune tellers and scientists. The difference is that a scientist can explain in a clear, unambiguous, and transparent language how he or she makes a prediction. It is vital that we operate as scientists, as this is the ethical part of the game. Thank you and enjoy the meeting and LandAware.
Here we are. Thank you very much, Faust. I'm not sure if he left already. I didn't introduce him properly, but I guess you all know him. I can say that, he's been working for a longer time as a researcher at CNR, directing that institute, but now he's inside the national civil protection, doing his job there. Katie, to you. We're moving to.
We're moving to Hero now, although I would just say that scientists are not always clear and unambiguous, and that's why we've got our communicating to stakeholders working group. So let's link up with those in moving forward. So now we've got Hero talking for us. Hero, I'm sharing the slides for you, aren't I? So I shall share my screen. Okay, hopefully everyone can see that.
Okay.
Yep.
Hi, this is Hiroaki Nakai again, a chair of Working Group 1 catalog, together with Gloria from Norway. I'm honored to present my case about Japanese landslide early warning system and recent Kaizen, which is a steady improvement, steady but gradual. We all are facing together the same challenge, one way or the other, over the planet, be it the climate shift or COVID-19. Now, landslides and threat thereof are the 7 common destiny for us. And now I have put here a Japanese land, which is situated far east, a land of rising sun. We have an encyclopedia of geology. All kinds of geology, mostly, can be found on this island, archipelago. And here I have put the precipitation diagnosis chart. Previous one, please. Previous one.
You've got it set on a, there you go.
Oh, okay. The rainbow chart, which is a combination of long-term index and a short-term index. I will explain to you later. Antecedent precipitation index and 60 minutes rainfall combined together in a rainbow type of chart. So we can show a soil moisture risk level all over the country, 1 kilometer by 1 kilometer. Next, please. Now, having said that, loose landslide early warning system is a solution depending upon natural conditions, both natural conditions and social conditions. It's a sort of a compromise between those two. Social conditions, by which I mean, it's a demand from local first responders. On the other hand, natural conditions are climatological, geological, and seismic. They are hard to be predicted. Diverse in geological terms, Japanese land has been made to an equilibrium. It strikes a certain balance between the high intensity rain and very fragile and hazardous soil. For social, Japanese culture is more or less just-in-time kind of system. It's a sort of a culture. People need lead time, but much shorter than those of the continent people. The people require 2 to 3 hours for a lead time. People wanted to stay normal to the last minutes. And okay, I'll go with that. So that therein arises the following due questions. The rules in Japan, how reliable should it be? Of which parameter sets are to be chosen? How open the data set? to users? On what scale should we go? How often should it be revised? So that for reliabilities, those triggering events, triggering heavy rainfall is record breaking by definition. So for parameters, especially for antecedent precipitation index, which is called soil moisture index in Japan and soil water index in Japan, they are combined products from radar nowcast in Japan. It's a short range product instead of 4-dimensional assimilation for weather forecast. So for the openness of data, Japan has chosen 3 hours instead of 6 or 15. If that were 6 or 15, our technological integration would be more focused on 4-dimensional assimilation of weather forecast. But for 3 hours or 2 to 3 hours, we have to rely on radar forecast. Now, it is revised every 5 years in Japan. And for this slide, I will show more detail because of time constraints. The precipitation database has been retrospectively upgraded for machine learning. In this time of data abundance, we have to learn from data, but through machines. Here I have shown just a picture of technical detail. I'll go ahead, please. Better renovation, technical detail. Okay. For technical detail, downscaling. Radar chart, those chessboard type mesh-based products from nowcast has been dissected. Now it's up to 1 kilometer now. Given the longitude of in Japanese band, it is not 25, but 5 by 6 mesh here. And there are certain rules to summarize certain parts, like looking at the adjacent meshes grid to take some maximum value for that. Please, next, please. Okay. Now, Japan is undergoing a massive weather radar network renovation. The resolution gets higher in terms of azimuth to 0.35 degree, and also the conform noise from radar is now being removed, and like chaff, wildfire haze, insects, non-precipitation noises has to be removed, and now it is removed. Back, please. An adjustment via KDP, because we are shifting from single polar to multipolar, actually bipolar. We can use adjustment via KDP. So now we got more fine nowcast picture now. Next, please. Earthquake. Earthquake is a headache for Japan. As a nation, Japan is now facing a constant earthquake, the vibration of ground. And now we have to adjust the cutoff threshold each time we face earthquake, which is part of my daily operations, day in and day out. 2 days ago, we have a strong earthquake in northern part of Aomori, south of Hokkaido. And for those earthquake, we take local emergency physical measures for each slopes and ravines. But for other ones, especially territorial ones, we have to adjust the cutoff by cutting and lowering the horizontal axis by 70 to 80% of the normal level. We adjust the cutoff. And my study this year shows that those cutting or shifting the threshold may not always be necessary. So I'm still constantly studying for that. We'll be doing Kaizen, gradual improvement. Next, please. Next, please. Okay. Just a previous one. Okay. I'll go with that. The sustainability maps must be revisited. Japan has stockpiled for the past 23 or 24 years the number of disasters. It is now 17,000 after the quality check. Those fruits of past effort, especially thematic map, analog maps, must be compiled together to show some sense of frequency map of landslide occurrence. And this is a map created and published this year by myself, my colleague. And those sustainability maps need to be reflected to the operational landslide early warning system as well. This is just a map. The map must be combined together with precipitation daily values. We update the nowcast every 10 minutes all over Japan, 1 kilometer by 1 kilometer. And those precipitation indices must be combined together with those more static sustainability map. Next, please. Next, please. Okay, short remarks. Now, we have experienced many bad examples of good legacy system, which can be in a short time outdated, get it black boxed, and users and operators cannot join to improve. But for from Japanese experience, this is my notes. Loose is and needs to be an evolving system, and those components, modules, needs to be open to technological upgrading. And here I put my stress here. Decentralized operation to produce future generations of innovators from among current operators. So this is my philosophy or belief. This sort of wisdom of math. Managerial involvement of many is far better than one mastermind, which I learned from my teacher. The tsunami system in Japan was created by one master. It faced a hard time to update. Now, Japan, densely populated, urbanized with rapid development. Now, so far, Japanese people have chosen short-range products, but we know, we may change. Now, loose landslide early warning system is a cultural product. It's not just a technological product. It's a cultural product in essence. So we have to study the response culture. So reflecting over difference among region is productive. So that's why I'm chairing a working group catalog. So that will be a valuable initial product for this LandAware effort. Thank you for your attention.
Thank you ever so much, Hiro. I'm sorry, I think you've got some automatic settings on those slides.
Okay. Right.
Going through at their own time. I'm perfectly in time, so thank you very much. So next up, we have got Rosa. Rosa, are you okay to share your screen?
I share it, if it's okay with you.
Yes, please.
Okay. Yeah.
You okay?
Yeah, just hold on a sec, because I don't know where it will show up, in which screen. Okay, yeah, so this one. Oh, wait.
There we go. Yeah, it's started.
Can you see it?
Yeah, it's just coming in.
Great. Okay, so I'm Rosa, and today I'm going to present the regional landslide early warning system for Catalonia.
We haven't got the presentation Rosa, we haven't got the presentation
No?
yet. Just this says you're sharing your screen, but there's nothing actually come up.
Oh, wow. Is it now?
Still not quite there yet.
Wait, I'm just gonna do it again.
Just try again.
Just in case. Okay, now?
There we go. Yep, we've got it now.
Perfect.
Thank you.
Okay, so as I said, I'm going to present the regional landslide early warning system for Catalonia, our recent advances and future steps. So we will start by having a look at the main characteristics of the landslide early warning system for Catalonia. We use radar rainfall observations as an input data to assess if a landslide can be triggered or not. And we summarize the warnings into a 30-meter, from a 30-meter grid cells to a sub-basin warning map, which basically displays the maximum warning level that has been issued within each of the sub-basins of Catalonia for each time step. But we keep the 30-meter resolution map, and you can always have a look at it when zooming into the area that you are interested, because it shows warnings. And we update the results every 30 minutes. So here I wanted to show you an example of the landslide early warning system during the Gloria storm. It was an extraordinary rainfall event that affected all Catalonia last January. And it was very interesting for the evaluation of the performance of our landslide early warning system, because many landslides were reported, especially at the northeast of Catalonia. And well, and some affected houses, other affected roads, other affected parks, and we had many reports. So we used it for the evaluation. The aim of the landslide early warning system for Catalonia is to give the warnings to the authorities who are in charge of managing the risk, but it's still not operational, and we're running it in real time at the university servers in Barcelona for testing purposes. So additionally, we also produce a daily summary for subbasins, which displays the maximum warning level that has been issued during the day, every day at 24 hours. And we use it for a quick check to see if the warnings made sense or not during that day. So here you can see the rainfall accumulations during the 22nd of January, which was the day shown at the animations in the previous slides. And the rainfall accumulations were very significant at the northeast, and it coincided with the area where most of the high warnings were issued. And as I said, we were very happy because many events were reported, and we could check, and yeah, it made sense. Like most of the events were reported in the locations with high warnings. Now that we know how the landslide early warning system looks like, we can go a little more into detail of the methodology that we are using. The landslide early warning system for Catalonia combines two input parameters. The first is susceptibility, and the second is radar rainfall observations. So for the susceptibility map, we have used slope angle and land use and land cover information, and the resolution of it is 30 meters. And radar observations have a resolution of 1 kilometer, and we update them every 30 minutes. So once we have the susceptibility and the rainfall observations from radar, we need to assess if the rainfall has the potential of triggering a landslide or not. And we do it with this set of rainfall intensity duration thresholds. And well, a rainfall event has a given duration and intensity, and we can classify it according to one of these four rainfall warning classes. And so the only thing that's left is to combine the rainfall warning and susceptibility to issue a warning. And we do is using this warning matrix, which basically has the rainfall hazard in the x-axis and the susceptibility in the y-axis and susceptibility in the x-axis. And for each grid cell, we can obtain a warning for each time step. So in our case, increasing the warning level implies increasing the possibility of having a landslide. Therefore, if we issue a very low warning, it means that the possibility that a landslide is triggered is very low. And if we issue a high warning, it means that the possibility of having a landslide is high. But there is many uncertainties that challenge us. For example, we have the uncertainties that affect the susceptibility map, the uncertainties that affect the rainfall data we are using that can be either errors in the radar QPE rainfall values, but also come from the small scale variability of the rainfall data within the 1 kilometer radar grid cell, which we cannot assess because the grid cell is too large. And we also have uncertainties from the definition of the rainfall thresholds, which has been done empirically, and from the definition of the warning matrix. And all of these uncertainties influence the resulting warnings and therefore influence the performance of our landslide early warning system. Another important challenge that we had to face is the availability of a landslide inventory that could be used for the evaluation of the warnings. And in order to be able to use the inventory for the evaluation of the landslide early warning system performance, all the entries had to include the time and the location of the landslide events, and the inventory has to be as complete as possible. But it was not the case when we began our work. So that's why we created this Lavicat Inventory, which is a collaborative initiative. So people who observe a landslide can just tweet it and use the hashtag Lavicat, and we collect this information to make the inventory. But it turns out that most of the landslide reports, location and time is approximate, and the inventory that results from these tweets is biased towards areas with a high population density or areas that are close to infrastructures. So this adds uncertainty to the data set that we use for the evaluation of the performance of the system. So in this example, you can see what happened when we used a traditional verification method. And sometimes you have a landslide report in a location where a very low warning level is issued. And if we used a traditional verification method, we would check the warning at the location of the landslide report and say, okay, in this case, the landslide early warning system did not perform well. But I think that, well, you can see that these landslide reports were made very, very close to grid cells with a high warning. So I think that the landslide early warning system in this case does not do that bad. And that's why we started using fuzzy verification methods, which are great because they allow us to to fuzzy assess the quality of the warnings and help us dealing with the uncertainties of both the landslide early warning system parts and the inventory. Well, and more of this, if you are interested, we're preparing a paper, so I will be happy to share if somebody wants to read about it. And well, so we still have a lot of work to do. To begin with, the landslide early warning system for Catalonia only uses information on the triggering rainfall to assess if a rainfall event can trigger a landslide or not. But we do not take into account any predisposing factor. So that's why we plan to use information of soil moisture to try to include these predisposing conditions and hopefully improve the performance of the landslide early warning system. Also, as you have seen, our landslide early warning system in reality is not early because we are issuing real-time warnings. So we plan to move from real-time warnings to forecasts. And this can be either done by including radar nowcasts or numerical weather prediction for medium range filters. And by doing this, we will be able to issue the warnings before the landslide should be triggered. And we think that we would help a lot the authorities who are the ones that have to use our data to act in advance. And yeah, that's all. Thanks.
That was great, Rosa. Thank you. That's really interesting and very much on time. So no prompting necessary. Thank you. I'd be definitely interested in that paper. So I think if other people are as well, then we can collate a few people who might be interested when it's published. That would be great. So next up, now we move to Central America, and Graciela, I think, is going to go first and give us a little video presentation giving examples of a couple of landslide early warning systems in Central America. Is that right, Graciela?
Yes, I will try to share the screen. Just want to say that the presentation was done with the other 4 members of the LandAware, and you will find the name, and I use my voice to put together all the information. Yes.
We could see it, but we couldn't hear anything.
No, I will. There.
No,
Can't hear you. We know it worked earlier.
yeah, yeah.
Mm?
That's
We
right.
know
We
it
cannot
worked earlier.
hear.
We can't hear you.
No?
We know it worked in practice.
Again.
So just while Graciela's doing that, if anyone has got any comments or has written any comments in the chat, we're kind of answering a couple of them and making notes of questions to ask people. So please do make use of the chat if you can see it and if you have any questions for the presenters so far.
Sorry, I have to
It's
close
fine.
and open
We're on
again.
late technology, don't worry. It did earlier work, we promise. We can see you. That's fingers crossed.
Presentation provides
It's
an
working
overview
now?
of
Okay.
efforts made to
you.
organize a landslide early warning system in Central America since the beginning of 2000, and in particular in the countries of El Salvador, Honduras, Nicaragua, and Costa Rica. The region has a long history of deadly landslides caused by rainfall and earthquakes, and the most recent ones occurred last month, triggered by the rainfall associated with the tropical cyclones Eta and Iota. A national system is operated in El Salvador since 2005 by the Observatory of Hazards and Natural Resources, which is part of the Ministry of Environment and Natural Resources. The system uses the so-called Central America Flash Flood Guidance System and landslide model, in which there are 5 main components: the landslide susceptibility, the average soil moisture, the daily rainfall from NOAA and SD, the relation between one-day average soil moisture and one-day precipitation, and the threshold applied to high and very high susceptible areas. The landslide hazard index is daily obtained by combining susceptibility factor and triggering factor using an heuristic approach based on the Mora-Varson model. And the index is reclassified in 5 categories from very low to very high. The result of this analysis is an impact-based forecast that is daily sent in the different warning zones, which in the case of El Salvador are the different municipalities. Future plans include the organization of local systems for critical areas and the revision of threshold based on event rainfall measurements. In Honduras, landslide early warning systems are very limited and mainly at local level. The Municipal Emergency Committee, CODEM, operates two local systems at El Berrinche landslide and El Reparto landslide, both affecting the capital city Tegucigalpa. At national level is the Contingency Permanent Commission, COPECO, which is in charge of issuing warning when critical meteorological events that can trigger landslide and flood are approaching the country. Among the challenges, we mentioned the lack of meteorological landslide data which are necessary to perform reliable landslide hazard evaluations, and also the constant increase of population living in high susceptible area. To overcome the first challenge, the academia has started a systematic analysis of temporal and spatial occurrence of landslide around the Tegucigalpa area by reviewing rainfall thresholds and susceptibility maps. In Nicaragua, efforts to organize a local and national landslide early warning system have been made and coordinated by the National Institute of Territorial Studies in ETER. The first system was local and installed at 4 volcanoes to predict lahars. Rainfall stations that could measure hourly data were located closely to existing seismic stations. The presentation provides an overview of efforts made to organize landslide warning system in Central America occurred in October 2000, and in particular in the...
Sorry, I don't know what...
You all right, Graziella? She suddenly kicked in a voice from somewhere. You got many slides left? Do you want to unmute?
No, just three or four, not more. Okay. I should have maybe presented myself. Okay. I try again if it's not.
If it's not, you can, the last few slides, you can say a few words by yourself.
Yeah, have you got it without any without any recording?
Yeah.
Yeah, I have to find it. Okay, I will try again with the recording. If not, yeah. I don't know if maybe still there are some problem in this. I'm wondering, I can mute my microphone when I have this presentation.
It's not a problem. The microphone was not a problem. You go ahead as you did. Try again. Otherwise, we put Wilfred and we move on.
The first system was local and installed at 4 volcanoes to predict lahars. Rainfall stations that could measure hourly data were located closely to existing seismic stations. Since the system was installed, lahars occurred only at Concepcion volcano. The first lahar occurred in October 2002. The alarms was never released because the rainfall threshold were too high, but the warning were sent based on geophone informations. The second system was also local and installed in the northern part of Nicaragua. It included a rainfall station, geophone and sensiometer in order to predict the movement of deep-seated earth slides. In 2008 was created a system for national warning purposes that download the precipitation estimates from NESTI every 50 minutes and define the critical rainfall value at each landslide site registered in the database using intensity duration curves. If the accumulated precipitation is above the defined threshold, an alert message is sent for each landslide hotspot. The system can produce also precipitation estimates for active volcano in all Central America, and was recently tested during the Hurricane Eta and Iota. An attempt to produce a national landslide early warning was made last month during the approach of Hurricane Iota by combining soil moisture data and rainfall data. A short report was sent only to the stakeholder with a map showing in which region landslide could be expected. In the future, the plans are to complete the database with recent landslide events, but also to organize all information related to local and national system in a more systematic way and create a warning portal and define better landslide thresholds. Also in Costa Rica, the landslide early warning system are very limited and mainly local. The few local systems are operated by the National Emergency Commission, like the one at La Torres Irasu volcano, which is operated since 2011, or the one at Landslide Masis in Sant'Anna, operated since 2018. Also, there are few cases of slope monitoring in the southern part of the San Jose capital city since 2010. There was also a local system at Orosi volcano, but now is dismissed because it never worked properly. Thank you for the attention.
We got there in the end. Thank you ever so much.
Sorry.
Thank you. So next up, we then have a talk on the Landslide Early Warning System Central America and why it's not working yet by Wilfred. And Graziella, am I right in you're sharing your screen, or is Wilfred sharing his?
No, I think he will share.
Is he sharing his own? Brilliant.
Wilfred, are you there?
Okay, good morning, everybody.
Good morning, Wilfred. We can hear you loud and clear.
From Nicaragua. Well, I'm trying to share my screen. Can you see it?
Not yet. We can just see you.
Yeah. Okay. Now?
We've got the black screen, so as soon as we get an actual presentation, yes, we're in.
Okay.
Thank you very much.
Well, I'm working in Nicaragua mainly the last 30 years. I'm originally from Germany, from Potsdam, from the Geosciences Institute in Potsdam, but I came to Nicaragua as a seismologist in 1989. Well, how to continue? Okay. From my presentation from ResearchGate, well, you can see that I'm mainly working in seismology, tsunamis, also somewhat in landslides, volcanology, GIS, disaster mitigation. And my main programs I'm working in the moment is the tsunami Advisory Center for Central America and establishment of earthquake early warning in Nicaragua and Central America. And I'm working very much in the UNESCO Intergovernmental Coordination Group of the Pacific Tsunami Warning and Mitigation System. How came that I'm now also working in landslides? It was a very sad event. Hurricane Mitch affected Nicaragua and all Central America in October, November 1998. Very heavy rains. You can see in the map to the right side of this slide, the red line indicates a place in Nicaragua where the rain intensity was extremely high. In a few days, 2 meters of rain were coming down, and this place is exactly the volcanic chain. So there were many landslides in this area, but also in the mountain areas of Nicaragua. Many people died. I was in this time the director of the geophysical department, and I had to do something, but I didn't know too much about landslides, nearly nothing. What I did was I sent an email to the volcano email list, which existed in this time already, and asked for help. And many people answered, and I was able to put together a working group, a task force, and in 2 weeks after the event, we were already working on the Casita volcano. Here you can see the photo of the landslide of the Lahar. It came down from the top of the volcano. It's not an active volcano. The length is 15 kilometers and the width in this it is up to 4 kilometers. 2 villages were existing in this area, both were completely erased. Nearly all people died. And while we had to work in this area with this bad smell of dead people, and it affected me a lot. Well, so I came into this landslide business. We continued working on it with the civil protection and doing scientific work. And what was the cause of the high death toll of Hurricane Mitch in Nicaragua and also other countries? The hurricane stayed for a long time north of Honduras, several days. It was staying there, and we had so extreme and long-lasting rains in Nicaragua and Honduras. But it was also our lack of knowledge and preparation in scientific institutions, civil protection, and in the population. Imagine about 6 weeks before this event, I participated in an early warning meeting in Potsdam. It was a very big international meeting. And in this meeting, the director of INITER told us that in Nicaragua, there is no important landslide risk. He was completely wrong. Well, in Guatemala, to continue in other countries, I participated a little bit in the investigation of landslides caused by Hurricane Stan in 2005. Many people were killed in the volcanoes and other sites, and there were even tsunamis caused by lahars coming down from Atitlan in Atitlan Lake. And I became aware that the lahars in these volcanoes occurred nearly at the same time. There were only, let's say, 2 hours time difference between them. Another important event which I experienced was in El Salvador, 2009. Again, Hurricane Ida. It was not in the country. It was at a large distance from El Salvador, but caused these rains. And I became aware again that there was a big possibility to do warning but the monitoring agency did not know actually about this strong rain, because it did not show up in their monitoring meteorological station, but it did show up in the Nestis data, as I later became aware, and also in the seismic recordings at the volcano. So 200 people died. They had only to run maybe 100 meters to be out of the dangerous areas. And they were capacitated, they knew about it. There was a local landslide early warning system, but they were waiting for the official warning, which never was emitted. People in El Salvador learned a lot from this event. You saw in the presentation of Graciela that they are very well organized in El Salvador, and they have, I think, a rather good system. Well, now this year, last month, in November, I was very afraid that the hurricanes Eta and Iota could cause again a big disaster in Nicaragua. Fortunately, it was not the case. The hurricanes passed very fast through Nicaragua, and the precipitation was strong, but it was not so, the duration was not so long as in the case of Hurricane Mitch. But I became aware, observing the warnings which were emitted by our institution, INITER, that there were only general warnings with the information provided by NOAA, by the Hurricane Warning Center for our region. But there were no special warning concerning landslide for the public. So now, thinking about the last decades, it seems to me that in none of the important precipitation caused landslide events in Central America, inadequate warning was given to authorities or population to enable actions before the impact of the landslide. We had good experience for smaller lahars. Graciela mentioned some of them in Nicaragua, but we did not succeed to establish a good system. What we did after Hurricane Mitch was investigation. So this, I mentioned already, the International Task Force. We created the landslide unit at INITER. Graciela was the boss. We had a lot of international cooperation. We had a very beautiful GIS system. Dozens of geologists were capacitated. We had a lot of capacitation. We had initial steps for establishing a good monitoring system. But actually, thinking what happened later on, somehow the enthusiasm diluted in this area of work, that means landslides. And actually the landslide unit was transformed to a general geology department. And there were many other tasks to do, and landslides somehow went to a second order of importance, it seems to me. Well, we had a big investigation in 2012 about early warning systems in Central America. I only mention it. If somebody is interested, he can obtain the report. There was also written a guide for establishment and sustainability of landslide early warning system, which I prepared with the input of many people in Central America. And you can see here the map of the local landslide early warning system in Central America. I think many of them are not longer working in this moment. So I think there was a progress in landslide early warning in Central America, but it is surely not sufficient, especially if compared with early warning system on other dangerous phenomena. We have had in the last 5 years a spectacular advancement in the regional tsunami warning. We established last year a regional tsunami warning center at our institution in Nicaragua, which was developed in several years with Japanese and the help from other countries. This system is now working and giving tsunami warning and seismic information to all centers of Central America. We are just now in the process to establish national earthquake early warning systems in Central America. We started in Nicaragua. This is process is El Salvador, Costa Rica, and Guatemala joined. This is with the Swiss technical cooperation. It's a very advanced technology, software, and organization. And we will start to experimentally emit earthquake early warnings in the next year. So this has to be done in seconds for earthquake warnings and minutes in tsunami warnings. But we have not a similar process for landslides. Why? I think we have insufficient knowledge of local conditions. The most important part is maybe that our landslide groups in Central America are very small. I think in geology, in INETA are working maybe six or seven people. In seismology, we have 20 people. And they have also divided their attention to other tasks, as I also already mentioned. There's also a lack of interdisciplinary approach, and most of them are geologists. So there's little dominion of IT and software, instrumental monitoring, there's nearly nothing, very few monitoring stations, and little regional international cooperation. Might be also a problem of leadership. Leadership, I mean the bosses above the geology group, because they are sent to other tasks frequently and cannot concentrate on the earthquakes. And also, it seems to me we need a killer application for landslide early warning as we have it for tsunami warning and for earthquake early warning. So,
2 minutes, Wilfried, please.
Yes, I'm finishing. What to do? I think we need more consciousness in the scientific and civil protection institution in Central America about this situation for the landslide monitoring and early warning. We have to reinforce the existing departments or create new ones. We have to establish regional cooperation similar as we have it in seismology, to establish field monitoring and software solutions together. Imagine seismology, we exchange data from 400 or 500 seismic stations in the region. We are processing 2,000 times more data than the rain. That's the meteorological and systems in the region are getting. We cooperate. We should cooperate with seismology, volcanology, meteorology, hydrology, develop scientific leaders. And by my opinion, we should concentrate to the main problem which I see in the flows and lahars and volcanoes. And on the other hand, move people out of high hazard zones. My personal plans are this idea of the LandAware it's a very good one. I thank you very much that you established the system and that you invited me to this meeting. I will try to improve the software system for real-time mapping of precipitation and early warning for Nicaragua, Central America. And I promise to help and cooperate to the landslide groups in Nicaragua and Central America on methods for monitoring and early warning. And also exchange our experience with seismological groups on field sensors, data acquisition, transmission, and processing. Thank you very much. Okay.
Thank you very much, Wilfried. That was really interesting. Thank you. A good overview and key about collaboration, I think, moving forwards. So we've heard from all of our talks now, and I hope everyone agrees it's been an interesting afternoon with lots of case studies from around the world. There's some interesting chat going on as well in the chat. So first, we've got a couple of questions directed to presentations that we picked up earlier. So one that's kind of a bit more, I've assumed as being more for Michela and Manfred. What is the nature of games? Is it for propagating the importance of lose through games, or is it some sort of other approach? So you mentioned games early on in the working group overview. Could you just elaborate a little bit?
Sure. No, yeah. If the question is related, I answered in the chat and I said, if the question is related to the games that I mentioned when I was talking as an example of educational items, in my mind, they are educational games, to learn, to teach people the important features of Landslide early warning systems by means of game playing. But an important question there would be to who do you address these potential educational items? It's very important to understand, the stakeholders that you are actually trying to reach. Are they the final people, like common people, lay people that live maybe in some areas that are at risk? And then in that case, you should devise your objectives that then have to be played within the game, thinking about them, or is it other type of stakeholders? So that's if I understood well the question, that's my answer. And anyway, I want to say that if people want to get engaged into these not only game designing, but like designing educational items, and I'm very happy to discuss this within the working group.
I think that's a key point as well, because there's a bit of extra chat that we'll go into in a minute that will probably include more people in that the working groups at the moment are just for the initial setup of the LandAware network. So the people involved came up with 7, but moving forwards, our starting focus is 7, but in a year or two's time, or if anybody else wants to take on working groups, there's discussion about having new ones in the future. So this is not the be all and end all of LandAware by any means. This is just a means to get started. So that's possibly a key point for some of the discussion that's going in the chat. So there's a bit of, Roy asked a question about vegetation cover, specifically for Japan's one, but Hero did answer that and said it's quite a tricky topic. And I know that in the UK, we've had that issue as well. Roy, did you want to make any comments about your vegetation question?
Well, just that, I mean, it's been very well shown in a lot of areas, and in Japan in particular. I mean, I've been involved in research on that quite a bit for shallow landslides, both rainfall-initiated landslides, as well as even now earthquake-initiated landslides, that vegetation cover plays a big role in this, and it can affect the magnitude of landslides in a given area for a given storm with similar geomorphological conditions, anywhere from a several-fold up to an order of magnitude. So I'm just wondering, with the advances we have in remote sensing now at worldwide levels, why aren't we including that and updates on remote sensing? We ought to be thinking about including that in these early warning systems, because that could be in there as a dynamic factor. Tree age after clear cutting and then regrowth of trees. We know that there's a period of about 3 to 15 years after tree cutting that the root strength is kind of at a minimum, and that's a key factor for when these sites that are managed for forest harvesting are most susceptible to landslides. So I think that it wouldn't be a huge stretch to put that into a sophisticated early warning system.
Hey, Roy, this is Dahlia. I think we will definitely be exploring that with our data working group to identify the different remote sensing and in situ sources that are available. And so I absolutely welcome that discussion. I know we're incorporating that in some of our global and regional modeling and testing changing forest cover modeling at a regional scale. But that's definitely something we want to highlight and explore and identify the gaps on in our data working group.
Great. No, I think that's really good. If you would like to bring me into some of that, I'd be happy to do that. But I'm sure Ben's good at that as well, I'm sure. So, yeah.
Well, the working group won't be anything without its members, and so for anyone interested in joining, we really encourage you to join,
Okay.
and we'll be sending email around. So that's great.
Okay. I'm gonna sign off here pretty soon. It's getting kind of, I'm in Japan right now, and it's getting kind of late. So thanks very much, Dalia.
Thank you for joining us, Roy. So we've got another comment as well. If Hero, are you still here?
Yeah, I'm still here. I'm
You're
in Japan
also
too.
tired. You're also ready to log off in a minute. The joys of doing an international workshop, hey?
Yeah, actually, plant vegetation, they are a nice indicator of the health condition of mountain slopes. A good indicator.
Sure.
Nonetheless, I have a doubt. I'm suspicious about its effect, especially the root network system. Depending on the age of the forest coverage, or the species that covers the area. The bamboo, and this year in Japan, I have testified a lot of slope and landslides occurred in bamboo type of vegetation. So I think it is still in an early development stage to assess the condition clearly and in a persuasive manner over the globe. Thank you.
Bamboo's not a tree. Bamboo is a grass. And that's why it's not effective. It doesn't have, it has dense roots, but it's superficial roots.
Okay. Anyway.
Thank you. And another question for you, Hero, is will there be any component of earthquake-induced landslides included in the Japanese loos?
Actually, there are several. And nonetheless, for the loos, I have presented the precipitation index model.
Yeah.
At the same time, I'm running several systems as a promoter or an operator. So that's part of my effort. But for seismicity, we have another model, 1 kilometer, it's called the SUGDAS, as Seismo plus geology and geographical analysis system. So that's part of another agency. So I'm not chairing that. So that's why I didn't mention clearly.
Thank you. That was just a question in the chat. So that's good to address it as we're talking through. So in terms of the fact that we wanted this Q&A, or Michaela really wanted this Q&A to be focused on sort of the future of this network. Bye, Roy. The future of the network and things that we can address, bearing in mind that we've kind of done the startup based on the meeting that we had in Perugia in January so that we could get something up and running. There's been a couple of things in the chat that have kind of come out quite strongly. So first was a little key issue, and it's probably more related to Stefano because the actual initial question was answered by Joe. But there was a comment that one of the papers that related to California was, is it available online and is it in redacted Google sections, Google book sections? But there's a comment that maybe a goal of the educational group could be making classic papers better available to people who are interested in them. And I've kind of linked that into your education and sort of networking, Michaela and Stefano. Do you think that that's something that we could look at? Obviously there'll be a couple of copyright issues that we might have to address, but it could be something that could be added to your list of outcomes in the working group.
I think maybe we can share among us. Maybe we can build a shared library among us, because I don't think we have so big efforts on some big force like on book editors and so on. So I think the best solution for now is to create a shared library among us.
Yeah, and even if not a shared, sorry, Michaela, not even a shared library, then a shared, I have a copy of this paper if you want to see it, even if we can't share them directly, but a communication that we have access to different papers might be worthwhile. Yeah.
Well, indeed, you know, being members of a network is also sharing resources. That's what we said no, from the very beginning.
Yeah.
And indeed, you know, one of the aims you know, could be develop a library. That is something that we have there, and so we know that you know and we can even not only put items there like collect PDFs and share them internally, because that we can do internally. I guess we can share files even if they are copyrighted files. We are sharing it internally. But not only that, we get
no.
Sorry.
No, is there anyone attending from Springer?
No, I know. Yeah,
no?
maybe I shouldn't have said it
Okay,
like so loudly because it's a lot of people here listening. But anyway, besides that, I also welcome the idea that came. I'm not sure from who, but I already you know had it in the back of my mind within the educational working group. Classical papers. Remember also Fausto in his keynote was mentioning a couple that he liked a lot, very interesting ones. Classical papers can be told, or like we can have them recount, how do you say it in English? We can tell them to people in different ways. Now, besides reading them, now suggesting people you should read them, we can even create something out of classical papers. So I'm very much into that, and we can surely do it within our working group. And then I don't know if I have the time to get also on the other issue that Katie was mentioning before, the one about topics for working groups. As she said, I want to reiterate this. We created 7 working groups. It's 9 of us. It was 9 of us, you know, now it's more than 100, but it was 9 of us at the very beginning. And then we came up with something that indeed is like as the presence of territorial, geographical, regional working systems in these working groups is a majority, is major. Why? Because I didn't tell the whole story about how this group came about. The meeting in Perugia was a meeting invited, only meeting that we did in January before the COVID pandemic, but it was a meeting for regional landside early warning systems. And we came from another meeting. Graziella organized a meeting in 2016 in Oslo about national early warning systems. So no, the community really was born out of those meetings. Therefore, yes, there is a bias towards territorial, regional, geographical systems. But we have to definitely cover local systems also. And anyway, we have to add working groups. We have to add working groups as we move. You know, we just started. So like for a few months, maybe we can stay here. But then, you know, starting from 2021, we already are collecting some ideas. New ones maybe will come today. And please propose yourself as people that want to share. So like be leaders in working groups on either items.
Also, if I can add, we have to remember that some of the activity will be across among different working groups. So not necessarily they belong to one group. So we talk about the catalog, and this is both interesting for both having overview of local system or national system, but also involve the case of the terminology. And also there are other groups around the world that are working with terminology and nomenclature, for example, and this we have to take contact with them. So indeed, there are other topics that we are interested in, and this is just now a proposal. So we will work we will talk about this in the different working group meeting, and we will see what is common and what is different, and yeah.
Yeah, there's a lot of agreement for this in the chat, definitely. I'm saving the chat as well, so if anyone's got any extra points to fill in, then just contact us afterwards. It's completely fine. We're doing as much as we can in this meeting to kind of save people's viewpoints. So even if you're not unmuted and don't feel that you're contributing, if you write it in the chat, we will see it and come back to you. So please do use that. There's been a question on a positivity saying good luck to the network. Well, hopefully that includes you as well, so that's good. But my question is, what are the minimum and requirements of an existing complete landslide monitoring system for participation in the network? So Dalia, I've already seen you are happy to answer that one. Do you want to bob in with that one?
Sure. Well, I think this comes to a couple questions, which is, first of all, pooling and understanding what networks exist. So Fausto gave a great explanation of kind of how landslide early networks have evolved over time. And so I think in both the landslide early warning system network group that Hiro and Graziella, I believe, are chairing, as well as our group, I think the first action is to figure out what exists and who wants to participate. And then after that, it is to identify what are the, I won't say standards, but what are the kind of common elements in terms of, for landslide data, it's, are there metadata standards? Are there specific requirements or ways to bring in information that could be useful to multiple networks? And from the landslide early warning system, the question is what components are needed? And so I think as Graziella brought up, there's a lot of cross-cutting topics here. And so I see in the future, as our working groups are developing, we'll have maybe joint conversations to really talk about these cross-cutting issues of trying to capture what exists, identify gaps, and then pivot to how can we grow systems that maybe want to advance in landslide early warning and need tools or information from other groups. So the goal is really about knowledge sharing, which I think has been captured by many people here. And so really encourage participation in the working group so we can document a lot of these great comments that are coming in on the chat in terms of needs, both at the very local scale as well as regional and global.
Tied in there, well done. So there is a lot of questions about the fact that this meeting and some of the goals and the working groups do focus on the wider sort of regional and national forecasting. And there's a couple of questions about that some people would suit the slope specific information a bit more. So I did respond, forgive me, Manfred, I said that I think your working group covers a little bit more of the slope initial slope, sorry, oh no, the slope interpretation and slope modeling, is that correct?
Yes and no.
That's what I said.
I really would like to open this discussion and not give any personal opinion that is narrowing down the scope. I think innovations, they can be at all scales here, both in technology, in technologies, but also in ideas how to transfer this knowledge, communication. So I really, at the beginning, I leave this question unanswered. It can be all scales, and I don't want to give here a specific focus to this working group.
So, but if people's key focus was slope scale, because I know that we've got another BGS person on the call here and his work is specifically slope scale, not so much the regional stuff. Would we say that there's an opportunity for another working group if people want to set one up? How many are we monitoring it to in the near future? Michela, I know we wanted to talk about future plans.
Yes, for sure. Yeah, I mean, actually, we already recorded, besides the interest that is showing up in the chat today, we already recorded in your replies, your comments when some of you asked to become members of LandAware, that there is a question, specific question asking you whether you think of something that could be done within LandAware that is not there yet. and we recorded an interest for local early warning systems. Now I'm asking myself primarily, and then I'm asking all of you, do we want a general purpose working group called local early warning systems to deal with the many issues that are there within local early warning systems, or addressing the monitoring at local scale can be one item? Manfred is saying, innovations can be everything, whereas if we specifically say monitoring at slope scale, we are thinking about monitoring at slope scale. So we are open to proposals, open to detailed ideas, and also to general ones. So for sure, I can see from the interest that is being generated today in the chat, and some other people also mentioned it in advance, that there is we have to fill a gap that is indeed a gap of the world of the local systems. We can do it in different ways, and we will do it for sure. So we are open to that. In terms of just like today, it's a kickoff event. So I want to also explain something, how the structure of the network is and what is our vision for the future. As I said, but as we know, we discussed, of course, a lot more in our internal discussions. At the moment, the executive committee is 9 people. And so the beginning of this network for the first 2 years, it's going to be us. And then after that, every single working group that has a chair, the people that are chairing the working groups, by default, they will be part of the executive committee. So they will be part of the discussion, because of course we meet. We meet regularly as working group members, and then we do our job independently, and then the collective work comes at the central place that is the executive committee. So please be brave, if I can use this word. Maybe it's not the proper one, but be proactive and propose yourself for chairing specific actions, so for chairing new working groups.
Yeah, so there's a comment from Miriana. Thank you, Miriana, that says it'd be great if the group could not just gather together evidence and guides that are helpful, but also develop and write some generalized guidance as well. And I've just written back that, yes, Miriana, that is one of the key outcomes that the group wants to achieve, accessible and sensible guidelines, or just guides, even if they're not rules, but things that people can follow in all different situations. And there's also one from Vanessa Banks I've just seen saying that the UN have been developing hazard profiles that may be of interest to the group, and the groups may contribute to their development. So there's definitely, it's not just a focus and data collection network. It is something that the people involved want to have a little bit of an output that comes from this network. It's not just going to sit behind closed doors. So collaboration internationally is key in developing and not developed countries. See how the data collection, we know we have issues with data poor regions, so we're interested in gathering experiences from people who have had different working climates, different to their own countries. So yeah, there's a lot of focus moving forwards. Conscious of the time, it's 2:30. So this is where, well, 2:30 European time, sorry. CET, it's another hour. I have no idea in America or Japan. It's late and early, depending on where you are. But this is the scheduled time that we were meant to finish. Quite happy if people want to dip out, but if people want to stay in and start to sort of unmute and have a raised hand, we need to do this a bit carefully because there's still 105 of you. But if people want to raise a hand and we can see you on the grid and invite you to say something, then that would be great. We've got about another 15 minutes from sort of the committee's point of view if people do want to have an interactive chat. So is there anybody who wants to raise a hand either in the participants on the right hand side or on their grid view? And if anyone sees it, please say. It's all gone very quiet now. So there's no hands being raised. So that's easier.
I want to answer, as Katie said, we have a few more minutes. We said the maximum in 15 minutes we will stop. If you want to leave, of course, like 2 hours is long, you can. But I want to answer a question from Marcel, actually. Marcel wrote, why not rename the working group Operational National Landslide Early Warning Systems into operational without the national part? We had a discussion about it before, and we decided to go for national within a working group, and then we can do other things, because otherwise operational landslide early warning systems is basically everything that is there already at operational level. I know that there are connections and important things that make for operational systems either at local scale or at regional scale, but we purposely decided to stick with the national one that is an important subset, and then we can move on with others. Maybe we can say operational local. I don't know if Davide Bertolo is there. Yeah, he's there still. For instance, he is a manager of important. Please, if you want to add something about it.
Sorry?
No, I'm saying I was mentioning your name just because I'm thinking about you as being one of the people actually running operational local landslide early warning systems.
Yeah.
So we can definitely set up such a working group in the near future if we want.
Yes, I'm available. First of all, hi everybody. And for people who doesn't know me, I'm Davide Bertolo. I'm the chief of the Regional Geological Survey in the smallest region in Italy, and that's Valle d'Aosta. We are monitoring a territory who has a surface of 3,260 square kilometers. So is not a great territory, but we are in a very mountainous region, which has the Mont Blanc and Matterhorn, Italian side of the two massives. So we have a lot of landslides compared to our aerial extension. And yes, we have implemented recently a full-scale regional early warning system, and now I think that the challenge is most of all to integrate local and I should say site early warning system in a more regional and more integrated monitoring system. And once we achieved this goal, we could also think to implement this kind of model maybe to a national early warning system, taking into account then that many
Ona poveznica što si nam...
I'm sorry? Maybe.
I think she unmuted herself, so I quickly
no problem anyway, no problem anyway. But okay, that's a real challenge. I'm happy to be here today and to participate to this session. There is a lot of people that we can share our experience and grow together. That's very nice and very important. So I'm available and to show you what we are doing and during a session over the next month, and gather also some suggestions and other tips from everybody.
Okay, thank you, Davide. I also in the chat I see the opinion from Filippo Catani. If you want to express it also by talking, that's you have a different view on this. If you are still there.
Yeah, I'm there.
There is Aditya's that has raised hand. So after Filippo, maybe we.
Yeah,
Okay, sorry, I didn't
that's
see
a
it.
response.
Otherwise, we can go after, as you want. Okay. No, my opinion, I clarified the opinion by writing because it was easier to understand for everybody, but in general, as I wrote there, in my opinion, we would like to apply, to be able to apply as, for example, NASA did, with Dalia knows, something which is not only empirical, but is taking into account more parameters, like I've seen people speaking about vegetation contribution and so on. So the difference between a local early warning system and a non-local one is that we have to generalize, we have to avoid some variables. No? So it's data availability. We don't have the capability of putting instruments or monitoring tools everywhere in all slopes. So for this reason, we rely on different models, but this is only a problem of data availability. Since now we are starting to see that in the near future, we will be able to acquire data everywhere quite easily. It is, I see the local early warning system as an end member with a continuous change between very empirical models that requires few parameters, like only rain, like it's the basic model we know very well, everybody knows. To the complete end, the deterministic model, I don't speak about the three-dimensional numerical modeling of a very complex slide, but distributed numerical model, there are several examples. Now, starting from the USGS triggers model, for example, that they are potentially applicable. As Fausto was citing before, the very early contribution of Campbell telling that we were at that time already able technically to apply those models. We are now technically able to apply deterministic models at the regional scale. So I think we should consider every type of model, changing from the very basic empirical one to the more complete, as a range of variations depending on our capability to acquire data from satellites, mainly, in my opinion, going down to the field. And so why not discuss this already in every working group? No, because I think maybe, I don't know if Dalia, for example, agrees on this. That's all.
Hi, Filippo. Yeah, I think that's an excellent point, and I completely agree. I think that we want to make this group accessible to everyone that wants to participate, and that means that there's some areas with very little data. And so I think from the data working group, our idea was to identify what's out there, and almost, I don't know if you know the Choose Your Own Adventure series, but essentially, if you have these data products, here are the types of models that could be relevant. And then you kind of go more detailed, but characterizing and classifying what's out there and then kind of matching it to the potential modeling framework that would work at different scales, I think is a really, interesting avenue that I don't think we've really pursued holistically yet. So I agree, it has to represent all scales because, there's some areas that have very little data, and the increasing availability and opportunity to exploit satellite data is really changing the game, and cloud computing is as well. So I think there's a lot.
Fabulous. And Aditya has been sitting very patiently with hand up in the air. So would you like to make your comment?
Yes, thank you for the opportunity to be able to talk. Things I would like to add. Actually, some of my points were earlier discussed just by a couple of speakers here. I was wondering about the total evolution of the landslides. Some start as earthquake induced, and then it gradually weakens, and then the debris flows continue. Like, for example, the Wenchuan earthquake in China, 2008. So you see that the debris flows, some are really big, and even some nature communication papers that talk about holistic machine learning models that can include a couple of trigger factors multiple trigger factors actually. So from available data towards a holistic model of landslide early warning system must include a lot of trigger factors, and a lot of available free data can be processed, assessed, and maybe it can also be used to create a holistic model which can save lives. I mean, of course, the communities that would be affected by earthquake induced landslides in specific, or even places where it's hilly and you have a lot of rainfall, like Himalayas, for example, the geology is very fragile, and the rainfall is really high, especially from July to September or October. So if you're looking at early warning systems, I just wanted to make a small extra point that we need to include all possible trigger factors. Of course, vegetation could be on the second step of the early warning, where it's mitigation. But if you're talking about early warning itself, the trigger and evolution of landslides, I thought was important to look at. Thank you. And also, I would like to make an extra comment, sir. Michelle, sir, if any help I could give you on making the content for the e-learning group, I would like to help you.
Thank you for your comment, and specifically to your last question. Of course, we'll work collectively. I can say that I'm not going to send an email to people for the e-learning warning group right away. I will wait for next year, January, but then we will meet soon anyway for that working group as well.
So I think comments are kind of drying up, or at least being related to conversations that we're already having, and it is just about 1:45. So Michaela's going to wrap up in a second, but did we want to do some pictures of everybody on the screen or not?
It would be nice if we can.
If people
I'm
are happy
seeing,
to just
of course,
put their video.
this is the time. Let's say this is the time to switch on your camera if you want, of course.
Yeah, if you want.
But then,
if you don't want to, that's fine. I've got 4 screens, so you can still hide.
But then who's taking the pictures? Because then
I can take them.
Yeah. I'm also trying to do something, but we have multiple screens.
Okay, everybody smile. Cheese. Right, that's screen 1. You've got to keep smiling. Hang on. Screen 2. Screen 3. Keep smiling. Oh, this one's not so many cameras. Oh, come on. There's a lot of people looking a bit uncomfortable on that one. And screen 4 is also no videos on that one. But we've got the fact that we've still got 88 participants. So I think we've done pretty well to keep everyone engaged. So Michaela, shall I hand over to you for some closing comments?
Yes, absolutely. Let me just do a copy and paste one last. Okay. Well, the closing comments will be very, very brief. I'm not going to summarize what you just heard in the past 2 hours. We purposely decided at the beginning that we could have an extra 15 minutes if people wanted, and apparently you wanted it because it's still 88 of you there. I just want to thank you very much for having participated to this kickoff event. As we said throughout these 2 hours, it's a work in progress. It's many different people working in parallel as well, besides putting everything together. So many different working groups. If you are not a member already or an observer already, please join us. It's for free. We said it somewhere, I guess in the replies to the chat. We are not having a fee for now for being part of the network. And I just want to say, that thanks for being here, and stay tuned for news.
Perfect.
As for any virtual meeting, the very, very end is very difficult. What do we do now? We can say like, bye. You can say like, yes, exactly. Like reactions, Zoom reactions. And thank you very much. Bye.
Thank you ever so much. You can leave in your own time.
Bye.
Thank you.
Bye-bye.
Bye.
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 Everyone.
Bye. Bye. Thank you very much.
Bye.
Bye-bye.
Bye-bye.
Bye. Bye. Thanks, Miguel.